Okay, section 1.2.2, creating linear inequalities in one variable. So, we've talked about these before. There are 5 different types, well 4 that mainly we're working with, of inequalities. An inequality is the one that's not equal to, right? We actually have a symbol for not equal to. But anything with an equal sign is considered an equation. Anything without an equal sign or any inequality sign is considered an expression. And then you've got things like greater than, less than, greater than or equal to, less than or equal to. My apologies, this is the wrong symbol. Should be that one. Less than or equal to, those are the inequalities, 4 inequalities. Alrighty. Luckily, just like we saw last time when we were solving equations versus solving inequalities, there wasn't much difference between the two. Same situation goes here. You just have to pay very special attention to which inequality you want to use, because now you have more options. So that's really the only extra thing we're going to be doing in this chapter. Let's go ahead and dive in. Example 1. Juan has no more than $50 to spend at the mall. He wants to buy a pair of jeans and some juice. If the sales tax on the jeans is $4 and the juice is with tax costs $2, what is the maximum price of jeans that Juan can afford? Okay. Start with underlining. He has no more than $50 to spend. He wants to buy a pair of jeans and some juice. Although that's, yeah, okay. Sales tax on the jeans is 4%, and the juice costs $2. What is the maximum price of the jeans? Okay, so I took that and I underlined some important pieces, right? By now, that should be pretty routine with us. Alright, he's got no more than $50. Jeans have a 4% sales tax. He also wants to buy juice. It costs $2. And he needs to know the maximum price for the jeans. Since that is the only thing we don't know, we're going to make that equal to x. So that's going to be our x. Alright, let's build ourselves an expression/equation. So I'm actually not going to start with this first one. I'm going to start with the second one because I know that sounds a little more familiar. Here's x. X is going to be the price of the jeans, right? So the maximum price of the jeans. There's a 4% sales tax on that. So sales tax is in addition to, right? Think about that. So what's going to happen here? We're going to pay the jeans, and then are they going to be discounted 4%? Are we going to pay 96%? Are we only going to pay 4%? No, it's neither one of those. As super awesome as that would be. Sales tax actually says you're going to pay all of it and 4%. So it's going to be 104%. Just like it was with the bank account, right? They're getting more of our money. So this is going to be 1.04 times x. 1.04 times x. I'm going to write that better. Alright, and then he's also going to have a constant of juice, right? The juice doesn't affect the price of the jeans, so it'll be a +2 on the end. Very nice. We have an expression for how much the jeans are going to cost. How much are they allowed to be? Well, this expression here is going to be the total cost of the jeans. If he can't go over $50, is this going to be greater than $50, less than $50, greater than or equal to $50, or less than or equal to $50? Let's think about that very, very carefully. Can it be more than $50? No, otherwise he wouldn't have enough to spend on it, right? So it can't be greater than in any sense. So it can't be greater than or equal to. Can it be equal to $50? Can it be exactly $50? Yeah, it can be exactly 50, right? So it could equal. It could equal. Could it be less than $50? Definitely, right? That would be awesome because then you'd still have money to spend later. So it's going to be less than or equal to. So that's kind of how you can figure out which one it would work. Think about what it can be in greater. Can it be greater? Can it be less? Or can it be equal to? If you consider all three, then you know exactly which sign you're going to use. And we have our inequality. So notice, that was like virtually the same steps as an equality, as an equation, but the only extra part was you had to consider which inequality. Now we can just go ahead and solve it. So let's go ahead and solve that out. We can subtract the 2 from both sides, right? Subtract the 2, we get 1.04x is less than or equal to 48. And remember that other thing I have to worry about with inequalities, if I ever divide or multiply by a negative, what happens? I gotta switch the sign, right? I gotta switch the sign. And that didn't happen here because I'm just subtracting. So maybe it won't, right? But it's just if it happens, I have to worry about it, right? It's not I have to do this every single time with an inequality. It's if it happens, I'll worry about it. But it hasn't happened so far. I'll divide by 1.04. I am dividing, but it's positive, so I don't have to worry about it. Divide 48 divided by 1.04. You end up with x is less than or equal to 46.15. Now it's actually 46.15384615, right? But since we're talking about money here, right, x is the maximum price of the jeans, I'll translate it back to x can be 46.15 or less, right? If it's less, then that's fine. If it's 46.1 or 15, it's $46.15. Then he's spent exactly 50. That's cool. But if it's anything less than that, he can still buy them. If it's anything more than that, he can't buy them, right? So at most, 46.15 is another way to see that, or 46.15 or less. And that's an inequality. Let's go try another one. In fact, I'm going to let you guys try this one. Go ahead and pause the video now, try it out, see if you can do the same thing with as making an equation, but this time you're going to make an inequality. Go for it. Alrighty, hope you had time to pause the video and give it a try. Let's do it together. Alexis is saving to buy a laptop that costs $1,100. So far, she has saved $400. She makes $12 an hour in babysitting. What is the least number of hours she can make she needs to work in order to reach her goal? So I'll do some underlining. Laptop costs $1,100. She already has $400. She makes $12 an hour, and we want the least number of hours. So we got laptop costs $1,100. We have saved $400. She makes $12 per hour. And X is going to represent the least hours that she needs to work. I'm going a little faster because this should already be on your page. Okay, so you already should have tried this, and you should be editing now. So if you're wondering, why is she going so fast? It's because you didn't try the problem. So this should already be on your page. If it's not, then you need to try the problem next time. Okay, so now we'll build our expression. $12 per hour is going to give her how much she makes, right, times the number of hours, plus the 400 she has. And we're going to compare that to the 1100 laptop. Now the question is it going to be less than or equal to, greater than or equal to? Let's see. Well, so this over here represents the total cost, or how much money she has, right? And we want to compare it to buying the laptop. Can it be less than 1100? No, can't be less than 1100, otherwise she can't buy it. Can it be equal to? Yes, she can definitely pay exactly 1100. She'll have no money left over, but that's okay. Can it be greater than? Well, that would be awesome, because then she'd have extra money for, like, you know, decals or a fancy mouse or something like that. So it can be greater than or equal to. Sweet, we have our inequality. Go ahead and solve that now. So we translated. We're going to now solve. I've got 12x, so we'll subtract the 400 to the other side is 700. 700 divided by 12. To both sides, I've divided by a positive number, so I don't need to worry about switching the sign. X has to be greater than or equal to 58.3. In other words, she has to work over 58.3 hours. Now I've included the decimal here because it's not just 58. If she works over 58, well 58.2 is over 58 hours, right? But she still won't have enough money. So she's got to work over 58.3. However, if you said over 59, you would still be right. So be careful with stuff like that. Alrighty, that was it's pretty much the same as the last problem, right? So that shouldn't have been too crazy. If you have any questions, though, you can stop the video and ask them now. Alrighty. Let's do again with example number 3. A radio station is giving away concert tickets. There are 40 tickets to start. They gave away 1 pair of tickets for every hour for a number of hours until they have at most 4 tickets left for a grand prize. If the contest runs from 11 a.m. to 1 p.m. each day, how many days will the contest last? All right, underlining some important stuff. Giving away concert tickets, probably not super important. 40 tickets to start, though. Sounds pretty important. They gave away one pair of tickets. We'll have to look at that. Every hour for a number of hours until they have given away at most 4 tickets. That's a little weird of a sentence. We'll have to come back and translate that a little bit in a minute. Contest runs from 11 a.m. to 1 p.m. We'll also have to translate that, right? Convert units. How many days will the contest last? Each day. Okay, so let's think about this. They have 40 tickets to start. That's pretty straightforward. They have 40 tickets to start. One pair every hour for a number of hours until they have at most 4 tickets left for a grand prize. All right, so let's start with the first part. The one pair, that's going to translate to 2 tickets per hour, right? Per hour. And then they're also only going to run the contest from 11 to 1. Let's see, 11 to 12, 12 to 1. That's 2 hours each day. 2 hours per day. Right? So they're going to give away a total of, 4 tickets per day. 4 tickets per day. Alright, that sounds a little more important since all the questions seem to be asking about days, right? And then lastly, until they have at most 4 tickets left. So contest ends with 4 tickets left. At most. And that's a keyword right there, at most. So they can have 3 tickets left, but they just can't have 5 tickets left, right? They'll keep running until they have at least 4 tickets left. At most 4 tickets left, pardon me. 4 tickets left. Alright, so in that case, what is X? Well, X is our question. X is going to be the number of days the contests run. So days of contest. Let's see if we can build an inequality. Excuse me. Alright, so we have X number of tickets. X number of days, and each day they give away 4. Now, 4x, if we put 4x, that says that's 4 tickets per day, right? That's totally fine. What should I put, though, if it's giving away 4 tickets? If you're giving away 4 tickets, how is that going into my slope? Is it going up by 4 each day or down by 4 each day? It's going down by 4 each day, right? So it's subtracting 4x, 4 times each day, right? And then we started off with 40. So plus a constant 40. Another way to look at this, if you want, is you had the 40 and you're taking away 4 each day. That's totally fine if you want to write it that way. I was just going with, the second one is just our standard slope constant kind of equation. But either one of these, it does the same thing, right? So however you want to think about it. 40 minus 4 each day, or take away 4 each day from 40. Awesome. Alright, compare that to at most 4, right? At most 4, let's see. This number over here, whatever it ends up being, has to be at most 4. So can it be 5? No. Can it be 4? Definitely. Equal to. Can it be 3? Yes. So it looks like it's less than or equal to. At most, less than or equal to. And we have our inequality. So let's go ahead and solve that. Subtract 40 from both sides. You end up with negative 4x is less than or equal to negative 36. Now I will divide by negative 4. So x is less than or equal to 9. So the contest will run for less than or equal to 9 days. Okay, what mistake did I just make? Go find it. I divided by a negative, so I should have flipped that sign, right? That doesn't make any sense. Think about this. If the contest runs for less than 9 days, I'm still going to have too many tickets, right? If it runs too short, I'll have too many tickets. So that negative needs to be changed, right? I need to change that to a greater than. On the 10th day, the contest will be over, right? On the 5th day, the contest, I'll still have too many tickets in the contest. So that's why I had to switch it, right? So it looks like your inequalities, they validate that, right? Use that whole rule where you have to switch it. Makes sense when you think about it in the context of the problem. So this is at least has an A, 9 days. Or no fewer than 9 days. Or at least 9 days. Has to be greater than 9 days, right? 9 days or more. Something like that. But if it doesn't run for at least 9, then I'm still going to have too many tickets left. Alrighty. One more. Let's try one more just to really hammer it home. The time has come for you to open a checking account. The local bank is offering you a free checking account if you maintain a minimum balance of $200. You already have a savings with this bank, and you've saved $60. You decided to save money until you have enough to open the checking account, plus keep some money in the savings. If you deposit $15 a week into the savings, what is the minimum number of weeks it will take you to be able to open this checking account with at least $200 and still have $25 in your savings? So this is a very real-life situation. If you don't use a bank account, they will charge you for that. So if you have a savings account that has less than a certain amount, they'll start saying, you know what, it's not really worth it to us for you to keep this money here. We're going to start charging you until you put more in. Okay, so that's a very real-life thing. Trust me, it sucks. But so basically, we want this to work out in our favor. You want this to work out in your favor. You want a checking account and you want a savings account, so you got to keep money in both of them. So let's read this one more time and underline some stuff that is important. Okay, we're opening a checking account. That's just lead in. Local bank is offering you a free choice of checking account if a minimum of $200. Okay, maybe we'll underline that. You already have a savings account and you have saved $60. That sounds super important. Save $60. Decide to save until you have enough in the checking account, plus keep money in the savings. If you deposit $15 a week, that sounds important. What is the minimum number of weeks? That sounds like a question. It will take for you to be able to open this checking account with at least $200 and still have $25 in your savings. So, huge paragraph. I ended up underlining 5 things, right? So don't think again, huge paragraph, super big problem. Just read it. Read it before you decide anything about the problem, okay? Because it could be like a huge, huge paragraph, and then the answer is, what was his name? Or the question is like, what is his name, right? Because it could end up being something like that. So don't panic. Let's start with what we know. So we have 60, right? We want to deposit 15, and then we're going to need at least 200 in one and 25. So we'll do 200 in the checking, 200 in the savings. And then the question, so we'll call X, the question, the min weeks until open. Alrighty. Okay, so let's think about this for a sec. While they keep talking about checking and savings over and over and over again, at the end of the day, is it important to us that they need to be in 2 different accounts? It's actually not. When you think about it, the question is asking, when will you have at least 200 and still have 25? Or in other words, when are you going to have at least 225, right? You need 225. So let's just combine these. Let's make our life easier. You need 225 to open this account. 200 for the checking, 25 for the savings, but overall you're going to need their addition, right? So let's just make that one thing. When we do that, this becomes a very simple problem. I have X number of weeks times $15 a week. I guess I should have wrote per week here, right? Because it's not just 15. Per week. Plus the 60 we already have saved. And we're going to compare that to the 225 we need. Right? There you go. See, it's almost virtually the same problem we've been doing all day long. The only question is, what do we stick in between? Well, we need this number on the left to be at least 225. Well, at least means, could I have 224? Nope, that's not at least. So not less than. Could I have 225? Yeah, I can have 225, so equal to. Can I have 226? Yes, I can. So greater than or equal to. So this number on the left has to be greater than or equal to this number on the right. Alrighty, let's go ahead and solve that. So minus 60 from both sides, because I already have that, right? So to take that away, 225 minus 60, oops, that's going to be 165. So I need to make 165 more. Divide that by the 15 per week, and it's a positive, so I don't need to worry about changing that sign. 15 weeks. I end up getting 11. So x is greater than or equal to 11. In other words, I need to save at least, or you need to save, 11 weeks. That's not too shabby. Not too bad to opening a checking account. At least 11 weeks. Alrighty, then we will have enough to open a $200 checking account and still have 25 in our savings account. So that's inequalities. Notice, much shorter chapter than the last one, right? Much shorter section. Because inequalities are virtually equations. If you can do an equation, the only additional thing you have to think about is what inequality sign are you going to put. And then if you need to switch the sign, right? So it's 2 extra things compared to equations. That is all for today. If you have any questions at all, please make sure you get them answered. Otherwise, you may start your homework, and I will see you next time.